Hello, my name is Professor Angelo Rentis, and welcome to Module 11, Oxygen Requirements.
Okay, today we're going to be doing Module 11, which deals with growing bacteria under different concentrations of oxygen. The title of the lab module is simply Module 11, Oxygen Requirements. So in this lab module, we're going to gain some experience in attempting to grow bacteria under different levels, different concentrations of oxygen. As you probably know by now at this point in the course, some bacteria require oxygen to grow, some don't, and some are poisoned by oxygen. So let's just briefly go over the various classification terms we use when we refer to bacteria on the basis of their oxygen requirements. Aerobic bacteria are bacteria that require oxygen, and they cannot grow unless oxygen is present. Facultatively anaerobic bacteria do not require oxygen. They can grow either with or without oxygen, but they do grow better when oxygen is present at normal concentrations. We have bacteria that are aerotolerant. These bacteria do not require oxygen. They do not use oxygen. They are not harmed by oxygen. They are totally indifferent to the concentration of oxygen in their environment. They neither grow better nor worse depending on oxygen. They simply don't care. That's why they're called aerotolerant bacteria. Then we have bacteria that are obligately anaerobic. These bacteria are poisoned by oxygen. They will not grow if there is any oxygen present at all. And then finally, we have bacteria that we refer to as being microaerophilic. These bacteria do require oxygen because they use it to obtain the energy they need, but they're unique in that they can only tolerate low concentrations of oxygen. So we say they are microaerophilic. Microaerophilic literally means liking or loving low concentrations of oxygen. Okay, so let's take a look at what we're going to be actually doing in the lab today. I have washed my hands, I've disinfected the bench top, I'm ready to go. Now you're going to see in Module 11 that we're going to be working with a type of medium that is a fluid medium. It's called fluid thioglycolate medium. It's sometimes called thioglycolate broth. So it can be referred to by either name, either thioglycolate broth, which is what I think your lab manual uses as a label, or I have always referred to it as fluid thioglycolate medium, but either label works fine. I have here already labeled and ready to go 8 tubes of thioglycolate broth or fluid thioglycolate medium. There are many kinds of nutrients within this broth. Many bacteria will find this broth quite nutritious. But what makes this broth special is that it has 3 ingredients that you don't find in most broths. It has an indicator of oxygen level in the broth. This oxygen indicator that is used here is referred to as reazarin. It is reddish where there is oxygen present. It is colorless where oxygen is absent. And so having an oxygen indicator in the broth like this lets us know if most of the broth is in fact without oxygen because that's important for what we're going to be using it for. The second important ingredient is a chemical called sodium thioglycolate. Thioglycolate reacts with oxygen that is dissolved within the broth and removes, at least chemically, removes the oxygen from the broth. So any oxygen that's below the surface of the broth should be removed by the sodium thioglycolate. Finally, the third ingredient is agar-agar. This is a thickening or solidifying agent similar to gelatin, and you've been exposed to this before, but I'll just refresh your memory. There is a very, very low concentration of agar-agar used in thioglycolate broth. It is used at about 0.1% agar-agar. That's equivalent to 1 gram of agar-agar being dissolved in 1,000 milliliters of this broth. You might wonder why we would use a thickening agent, a solidifying agent, in a liquid medium. Well, what we're trying to do with this liquid medium is we're trying to make sure that most of the broth below the surface, is oxygen free. Now we're going to have some oxygen at the top. We can't avoid it because the surface of the broth here at the top is in contact with air, which has oxygen in it. But by boiling the medium before we use it, making sure there's sodium thioglycolate in the broth, we're able to remove almost all of the oxygen in this broth. However, if we just let the tube sit for a while, there will be a spontaneous mixing of the broth because of convection currents, unless we add a thickening agent. So we add agar-agar to a concentration of 0.1% as a thickening agent so as to minimize mixing through convection currents. If there's no mixing, then most of this broth that starts out without oxygen will remain without oxygen. So in a couple minutes, I'm going to begin inoculating these broths. I'm not going to do that right now because I want to show you something else. Something else we're going to use in this lab is something called a brewer anaerobic jar. Now, thioglycolate broth is great for growing organisms in a broth, but suppose you want to grow anaerobic organisms that really don't like oxygen. Suppose you want to grow those on a solid surface like an agar plate. Well, in order to do that, you have to have a chamber that you can put them in, and then you need to remove that oxygen from that chamber. The chamber we use anymore, very frequently, is the brewer anaerobic jar. Consists of a clamp on top here, a lid, and this lid has a neoprene gasket that goes all the way around near the edge. There is a rack within which we can place our plates, and there's also a place here where we can put the envelope of chemicals that will end up removing the oxygen from the air that's trapped in the jar. Of course, there's the jar itself. And there is a special envelope that is sold to us enclosed in a foil packet. As long as the little bag inside this packet is sealed inside this foil packet, that little bag will be ready to go, be ready to use. However, when I use this jar, what I do is I put the plates in this rack. I put the rack in the jar, And then before I seal the jar up, I peel open this foil pack.
Remove the bag of chemicals and
I stick it in the jar with the plates, and then I immediately put the top on the jar and then clamp it down with this clamp. Because as soon as I open this foil packet, the chemical reaction begins that removes oxygen from the air. So I get the plates in the jar, I immediately open up this foil packet and stick the bag in with the plates, seal up the jar, and within about 2 hours, all the oxygen that was trapped inside this jar will be removed by a chemical reaction carried out by the material in the bag here. This material is called the catalyst. Now, before I started doing my inoculations, I wanted to show you how I set up these plates, because we're going to be using plates in order to grow bacteria in the anaerobic jar. And if you've read the lab module, you'll know that we need to set up 4 plates for 8 organisms. We're going to put those 8 organisms on 2 plates that will then go into a normal incubator that will expose these bacteria to normal concentrations of oxygen. The other 2 plates will be the same 8 bacteria, 4 on each plate, but these 2 plates, these 8 bacteria, are intended to be put into the anaerobic jar and grown under an anaerobic atmosphere. Now you've noticed I've already labeled 3 of the 4 plates, and I'm going to just hold them up here. You can see how I label them. I don't know if it'll show very well. I just use initials. So the organisms on this plate, the labels are for Clostridium sporogenes, Crinobacterium xerosis, Bacillus cereus, and Lactobacillus acidophilus. You'll also know that, notice at the bottom of the plate here, I put an A. That reminds me that this plate goes into the regular incubator to grow aerobically. This plate has been set up with the other 4 organisms: Mycobacterium smegmatis, Staph aureus, Enterococcus faecalis, and Streptococcus salivarius. I'm sorry, it's a little hard to see. I keep moving it around. This also, you'll notice, has an A at the bottom, because these 4 organisms are going to be put in the normal regular incubator with the other 4 organisms, so that all 8 organisms, 4 on this plate, 4 on this plate, are going to be stuck in an incubator, a normal incubator, and will grow aerobically. These other 2 plates, let me get these out of the way. These other 2 plates are the 2 plates that will have the bacteria that are going to be grown anaerobically. I already labeled one of the plates. You'll notice it has AN at the bottom, and the organisms on here are going to be Clostridium sporogenes, Bacillus cereus, Crinobacterium xerosis, and Lactobacillus acidophilus. So I have 4 more organisms I have to label on the remaining plate. And the reason I didn't label this plate yet is I wanted to show you how I do this. You'll notice I have the plate upside down. The bottom is now in my right hand. The lid is sitting in my left hand. So I have the plate upside down. What I'm going to do is I'm going to divide the plate into 4 sections, into what we call quadrants. And then I'm going to put the initials of each of the bacteria that are going to go in each of the 4 quadrants on this plate. Now the 4 bacteria that are remaining are Mycobacterium smegmatis, Staphylococcus aureus, Enterococcus faecalis, and Streptococcus salivarius. Those are the 4 bacteria I have left to label on a plate. So watch how I do this. I take the plate, I make sure it's upside down. I have the outside surface of that plate bottom facing up. You can see the glare on there when I flash it. I'm going to take a Sharpie, and on the outside surface of the bottom of the plate, I'm going to draw 2 lines that are going to divide the plate into 4 quadrants. You can see what I did there. There's the 4 quadrants. And now I'm going to put the initials for the 4 bacteria. Mycobacterium smegmatis is MS. Staphylococcus aureus is SA. Enterococcus faecalis is EF, and Streptococcus salivarius is SS. And so, and I also, this is going to be in the anaerobic jar, so I'm going to put AN on the plate. So that's what the plate looks like after I've made it up. Divided into quadrants, and then the initials for each of the organisms, they'll be placed on the plates, that plate, written on the quadrants. Okay, so now that I'm done labeling, you'll notice I have all 8 bacteria on these 2 plates, which have A on them, so they will incubate aerobically. I have all 8 bacteria spread on these 2 plates. They're labeled AN, so these plates are going to go in the anaerobic jar and will grow anaerobically, if they can. Okay. So I'm going to move some of the stuff out of the way here, and then I'm going to start inoculating. You need to understand, I am not going to make you sit through every inoculation I do. I've already shown you in a previous lab module how to do aseptic transfer, and I also showed you in lab module, I think it's lab module 9, I showed you how to streak agar plates. All right. So I do need the cultures that have already been growing of these bacteria. Here they are. Now there are many more bacteria in this rack than just the 8 that I'm going to be using, but I got out the rack just because it was simpler. Okay, now what I'm going to do here is I'm going to what I'm doing right now is I'm making a diagram of one of these plates that has been split up into 4 quadrants. Here it is. Now what I'm going to do is I'm going to do what I refer to as a straight line streak of each organism in one of the quadrants. So obviously I only can fit 4 of the 8 organisms on this particular one, but whichever 4 are going to be on here, I will take the culture that they're already growing in. I'll use my inoculating loop to get some of the culture. And then I'm going to take my inoculating loop and I'm going to, let's say I want to put this first bug in this quadrant right here. I will touch the surface of the agar out here near the edge, and then I will drag the loop toward the middle and stop. And that will be what I call a straight line streak. Now let me draw that with a Sharpie and so you can see what that looks like. So what I will do is I'll take, imagine this is my inoculating loop. I will touch the agar near the edge of the plate in one of the quadrants, the one that's labeled for the organism I'm working with at the moment. And I will touch the agar and then I will gently drag across the surface of the agar, the loop, until I get to about there, near the middle. What I have done there is I have laid down a small amount of bacteria in a straight line on the agar surface. And so I call this a straight line streak. And what I intend to do is I intend to take each of the 4 organisms that are supposed to go on this plate, transfer them from the tube they're growing in, and do a straight line streak for each of them. Boom, boom, boom. Now, when you actually do the streaking, you can't see the streak. I'm using the Sharpie here for purposes of demonstration, but hopefully you get the idea how I'm going to do this, okay? So let me go ahead and inoculate a couple of the bacteria using a straight line streak. Okay, so obviously what I've done here is I've repositioned the camera. And I think I'm going to, let's see, I'm going to do this plate. Let's do this. Let's get that out of the way. So I'm going to start with the aerobic plates. Here they are. These are both labeled A. You should be able to see that. So I'm going to put 4 organisms on this plate. I'll put the other 4 organisms on this plate. And as I put them on the plates, I'm going to put them on with straight line streaks. So let me get this plate out of the way so it's not so confusing. So Again, if you look at this carefully, you should be able to see the initials CS, CX, BC, LA. These stand for Clostridium sporogenes, Crinibacterium xerosis, Bacillus cereus, and Lactobacillus acidophilus. So I need to identify, grab the tube that goes with each of the quadrants. So I'm going to do this one first, Clostridium sporogenes. Okay, there it is. This is the right one. I'm going to, if you can see it here, I'll bring it into frame. I can see a little better. There's the Bunsen burner. I'm going to sterilize the loop in the flame. I'm let it cool for a few seconds. And then what I'm going to do is I'm going to get a little bit off the slant and do a straight line streak in the quadrant that is labeled CS for Clostridium sporogenes. Okay, should be cool enough. As I've taught you to do in the past, pop the top, flame the mouth, go in and rub against the slant a little bit where there is some growth. You will pick up some bacteria by doing that. Flame the mouth, put the top back on, put the tube back in the rack, and now I'm going to grab the plate, which is upside down. I'm going to grab it with my left hand, lift it up, which leaves the top behind. I'm going to turn the plate over like this. I move the top over here. And now I'm going to take this and do a straight line streak for Clostridium sporogenes. Start at the edge and drag toward the middle. And that's it. Sterilize my loop right away. Set it down so it'll cool. And now I take the plate, I turn it upside down and put it back in the lid. I want to minimize as much as possible the amount of time that the surface of the agar is exposed to the air. So as soon as I'm done doing one straight line streak, I put the bottom back into the top. Let me do one more just to show you how this works. So the next organism I'm going to do is Crinibacterium xerosis, CX. Again, if you look here, you can see where CX is. It's up here. I'm going to take the Crinibacterium slant. This loop was sterilized and it has cooled. I'm going to pop the top, flame the mouth, get a little bit on the loop. Put the tube back. Oop, I should have flamed the mouth, put the top back. A little bit of a hurry here. I'm going to take the bottom of the plate, lift it up, and I'm going to start the outside edge, and I am going to drag the loop toward the middle and stop. I've just made a straight line streak. Let me find my loop here. Straight line streak of Crinibacterium xerosis. Now what I'm going to do is I'm going to draw on the plate so you can get a better idea of how this worked. Of course, I did this on the agar. What I did was basically this. Those black lines, those diagonal lines are meant to show you where the straight line streak is located in each quadrant. Now I have to do this for all 4 plates. I have to finish this plate and then I have to do the other 3 plates. I'm not going to make you sit through watching me do all the straight line inoculations. I just want to make sure that I explain to you carefully how I approach this so as to get the best results possible. Okay, I finished inoculating all 4 plates. Remember, 2 of them are labeled A. They are going to be incubated aerobically in the regular incubator. No special arrangements being made. The other 2 plates contain the 8 organisms that will be put into the anaerobic jar. I'm going to put the aerobic plates aside for now, and when I'm done doing this video, I will stick these aerobic plates in the incubator. What about the anaerobic plates? Well, what I'm going to do is take the jar and the rack, and I'm going to take these 2 anaerobic plates, put them upside down in the rack. There they are in the rack. Let's see, what's the best way to do this? Okay, I think what I'm going to do is I'm going to open up the envelope
and remove the bag.
So once I open this foil packet, the bag in here begins reacting with the air. So what I need to do is I need to get this. I don't know if you can see there's a little place on the side here that I can stick the envelope. And I'm going to stick it in there. I'll work fast. Don't want to tear the bag, right? Okay. So now the bag has been inserted. You can see it there. There's the bag. There are the plates. Now all I need to do is take the rack with the plates and the bag and drop it into the jar. Put the top on. Grab the clamp. Slip the clamp over the top till the screw is in the middle of the lid, and then tighten that screw down until it feels like the neoprene gasket that I showed you around the inside edge of the lid, till it feels like that has sufficiently compressed so as to make this chamber at this point airtight. So if this is now airtight, that means the only oxygen that's going to be in this chamber is the oxygen that was trapped with the air when I close the lid. After about 2 hours, the catalyst in the bag will have removed all the oxygen that was trapped in the jar, and these bacteria will only be exposed to an anaerobic atmosphere, an atmosphere that is completely devoid of oxygen. Now, of course, I still have to put these at the right temperature so they'll grow. So these are going to go in the regular incubator along with the aerobic plates, but you'll remember the aerobic plates are not going to be put into a jar. They're simply going to be placed in the incubator the way they are, which means they will be experiencing normal concentrations of oxygen while they're growing in the incubator, 37-degree incubator. These plates, because they're enclosed in a jar from which all the oxygen will have been removed, when I stick this jar in that incubator, those plates in the jar will not be exposed to any oxygen in the incubator. Instead, they will only be exposed to the oxygen, they will only be exposed to the air inside the jar. And the air inside this jar is anaerobic. It doesn't have any oxygen. Okay. So I'll put all of these in the incubator when I'm done shooting the video. Now, just very quickly, I want to inoculate one of these tubes. I'm not going to make you watch me inoculate all 8 of them. Again, I'm going to make sure I have sterilized my loop. It's off camera, but that's okay. I'm going to let the loop cool. I'm going to grab my first bacterium. It turns out the first tube of thioglycolate is labeled Clostridium sporogenes. I grab the culture of Clostridium sporogenes, pop the top, flame it, go in, get a little bit of the bug, okay, take it back out, flame the top of the tube, put the top back on, and now I take the tube that is labeled Clostridium, I unscrew the top, these are screw caps, I flame the top, the opening of the tube, and now what I'm going to do is I'm going to go, without mixing it much, I want to just go straight down the middle all the way to nearly the bottom and then come out the way I went in. Flame the mouth of the tube, put the top back on, and then flame the loop. And like I mentioned, the burner's off stage here. I didn't like having it so close to me because it's a little bit tight and I didn't want to accidentally get burned. So that's it. I showed you how I transferred one of the bacteria, and now what I'm going to do is I'm going to, off camera, transfer the other 7 bacteria into each of their labeled tubes, and then these bacteria will be left in this rack, and this rack with the tubes will go into the incubator, the regular 37-degree incubator. And because we boiled the broth before we put the organisms in, of course, after I boiled it, I let it cool. I boiled these tubes a couple of hours ago, so the broth was already at room temperature. But I boiled the broth to get rid of all the oxygen that I could. And there is sodium thioglycolate in the broth. They'll remove any oxygen that might not have been boiled off. But because of all those things, these broths are anaerobic, and organisms that are adversely affected by oxygen should be able to grow at least near the bottom of these tubes. So we'll have to see what happens. So that's it for Module 11. Thank you very much.